All right. Hey, everybody. My name is Dan Friedman. I'm a data center solutions engineer at Cisco, and I wanted to spend some time talking to you today about Cisco UCS C880A M8, which is one of our most recent additions to the C series AI capable servers that we offer. And I'm doing a little bit of catch up here. As you can see by the dates in yellow, this box was orderable back in October 2025 and is generally available as of January or last month. Due to, I don't know, I would say calendar challenges internal to Cisco. I've had focus in other areas and inadequate time to cover this until now. So this is a little bit late in getting to you, but I hope it's helpful to you nonetheless. Before I get started talking about the C880, if you haven't already seen it, then please watch my video on AI pods, as this is just one of the server options that fits directly into that architecture. All right, so this format should look familiar. However, in this particular presentation, we're just going to talk about the key messaging and value proposition points that you see on the slide while we're on the slide. So you're not going to use those points for navigation throughout the rest of the presentation. So getting into it, if I were to summarize the C880 M8 in one sentence, it's what I said earlier. It's the latest addition to our C series AI server lineup. And then in terms of unparalleled AI performance, what do we mean there? Well, the C880A features NVIDIA HGX Blackwell 300 SXM GPUs that deliver up to 11 times inferencing throughput and 4 times faster training speeds for large language models like Llama 3.1, 405 billion parameters, and that's enabled by Blackwell tensor cores, transformer engine optimizations, and NVLink 8 interconnects with 1.8 terabits per second of bandwidth. When I make reference to 11 times inference throughput and 4 times faster training speeds, the question is, as compared to what? And I believe the answer to that is going to be as compared to the C885 with the NVIDIA H200 GPUs in it, which up until the point of the release of this server was our most powerful server available. Okay, in terms of advanced CPU technology, this box is powered by Intel Xeon 6th generation Granite Rapids processors with up to 86 cores per socket, doubled memory bandwidth, and integrated AI accelerators such as trust domain extensions, advanced matrix extensions, data streaming accelerator, quick assist, and in-memory analytics accelerator, optimized for compute-intensive and hybrid AI workloads. When we talk about seamless integration and manageability, we're obviously talking about integration of C-Series, like the rest of our C-Series line, with Cisco Intersight, which is our SaaS-based management platform that provides centralized control, visibility, and policy management across distributed AI infrastructure, enabling scalable, orchestrated, and enterprise-ready deployments. Composable AI infrastructure just means that this solution fits in within Cisco AI pods. As I was mentioning, AI pods are a modular AI infrastructure that's designed for rapid deployment at scale in data centers or at the edge, supporting secure and scalable AI factories. Targeted use cases for this box include real-time large language model inference, large-scale model training and fine-tuning, high-performance AI pipelines, including ETL and multimodal processing, AI-native data centers, high-performance compute, and scientific simulations. Enterprise-grade security and scalability just means that the solution supports secure deployments through Cisco Secure AI Factory and offers hyperscale level AI performance with rock-solid CPU support. And finally, ecosystem and support. This solution is backed by Cisco's ecosystem, including AI pods, networking, security, and validation to ensure interoperability and robust infrastructure for AI workloads. So, hopefully that makes sense and kind of sets the playing field for what you're going to see in the rest of the presentation. It's a very high performance box. Um, and and as it says in the paragraph in the middle, right, it sets a new benchmark in AI infrastructure by combining hyperscale level AI performance, advanced CPU capabilities, and enterprise grade manageability. It empowers organizations to build secure, scalable, and composable AI infrastructure tailored for the next frontier of AI innovation, whether for AI training clusters, real time inference engines, or AI native data centers. It's compelling for enterprises that are advancing their AI capabilities. Now, I mentioned the C series lineup, and the other servers that we have in the lineup, just for sake of some comparison here, are the C885 and the C845A. So, just as a quick recap, the C885A is our fixed solution, meaning it supports a minimum and a maximum of exactly 8 GPUs. Those GPUs are NVIDIA H100 or H200, and this offered the highest levels of performance available before the C880 arrived on scene. The fact that it's a fixed configuration means that it's less flexible and also less serviceable. So specifically what we mean in terms of serviceability is that the 8 fixed GPUs come in what's called a GPU sled. And if one of those were to fail, you would not open up the GPU sled and replace the single GPU. Instead, you would have to send the entire GPU sled back to Cisco. And so during that time, the chassis is down, and that's why it is less serviceable. This chassis, at least initially, was intended primarily for training use cases, still is a very good training box, AI model training box. Okay. The C845, by comparison to the 885, is modular. It can support a minimum of 2 and a maximum of 8 GPUs per box, which means that customers can size it the way that they want and grow into it as they have additional use cases. It also supports the H100 and H200 GPUs, although these are slightly different SKUs than the ones used in the 885 and slightly less performant. So that doesn't mean that these boxes can't still handle training. They can, but you won't get the maximum horsepower that you would get out of the C885 and, of course, now the C880A. So, modular means that it is more flexible and more serviceable. So, from a flexibility standpoint, it obviously supports a wider range of use cases. Whereas the C885 was primarily for training use cases, this box supports training and RAG and fine tuning and scalable inferencing. So, we feel that this box will sell better by comparison to the C885 just because it offers a bit more flexibility to customers, right? To size it the way that they need and grow into it as they see fit. And more serviceable, I believe in this box, you don't have to return the entire GPU sled. You can actually swap out individual GPUs, which would make sense, right? Because if you start with a box that only has 2 GPUs and then you want to install the remaining 6, then it would have to be a serviceable hardware platform. Okay, so here is a quick introductory view of the chassis, and one thing to note is that the front of the chassis is where the heat exhaust flows from. And I've tried to use red arrows in this image to depict this. And what that really means for you is that you will face the front of the chassis to your hot aisle in your data center. And oftentimes, that's not the front of your back, it's the back of your rack, right? So just something to be aware of and keep in mind. On the left, in the yellow rectangles, I've highlighted on the top the fans. You can kind of see, if you look through the wire mesh there, you can see the fans for the power supplies. And on the bottom, you can see the connectivity for the chassis. And we're going to be zooming in on all of these components soon. In the middle, you'll notice that there's 20 fans to help cool all of the internal components that provide the unparalleled AI performance that we mentioned. And then on the right, you'll see a summary of technical specifications. Most importantly, when it comes to performance, the C880 UCS M8 features the new NVIDIA B300 SXM GPUs, which deliver up to 11 times inference throughput and 4 times faster training speeds for those large language models as compared to the C885A with the H200 GPUs. So this level of performance is enabled by the Blackwell tensor cores in the B300 GPU, transformer engine optimizations, and NVLink 8 interconnects with 1.8 terabits worth of bandwidth, which is how the GPUs communicate with each other within the chassis. Okay, in terms of business use cases, I'm not going to read this slide to you, but I am going to leave it for you for reference purposes. Obviously, for artificial intelligence, we already talked about the array of use cases that can be supported there, anywhere from LLM training to fine-tuning to scalable inferencing and real-time applications. We can also support HPC, high-performance compute and scientific research applications, and data analytics, right? Using GPU accelerated GPU acceleration for data preparation applications such as Apache Rapids and Spark. Okay, so let's get into the architecture view of the chassis and all of its components. And I've tried to use some color coding to keep information consistent across the different slides. So on the far left, you'll see that this is the front view. I'm using my mouse up here. You can see the Cisco logo on the front of the chassis. This is just an angled view of the front of the chassis as well. Lots of product specifications here, right? It's a 19 rack unit server. It can support up to 2 Intel Xeon 6th Gen CPUs, and you've got different SKUs depending on the workload that you want to host. You can support up to 32 DDR5 RDIMMs. I think you can go up to 128 gig DIMMs there, so roughly 4 terabytes of RAM. From a storage perspective, you've got 2 M.2 SATA boot drives with RAID 0 protection, where your operating system would get loaded, and you can support up to 8 PCIe Gen 5 E1.S NVMe data drives for your data storage for your applications. Okay, GPUs, the only option here is the 8 NVIDIA B300 air-cooled GPUs, and those are located within the GPU sled. And we're going to see some additional slides that kind of show exactly what that means. And then from an east-west traffic perspective, meaning GPU to GPU communications between different chassis over the same backend network, we've got integrated ConnectX-8 NICs. Both of these components, both the GPUs and the ConnectX-8, support PCIe Gen 6, so even faster speeds than what we had before. Okay, so the GPU sled throughout the slides is consistently going to be shown in orange. I think except for on one slide, it's shown in blue. It's not super significant. You'll see why. And then the CPU sled is shown in red. And the CPU sled obviously contains the CPU, it contains your memory, it contains your data disks, your boot disks, your management cards, and your north-south network connectivity cards. Okay, so this is how clients would basically reach the applications running on the server through a front-end network. Okay, and then from a cooling perspective, we've got 20 fans that I showed you in a prior image, and you'll see that again. And then you've got a whole bunch of different physical I/O options, and the power supplies. There are 12 3.2 kilowatt N+N power supplies running at 50 volts, right, which draws a little less power, generates a little less heat, which is obviously significant since we're already generating a lot of heat with the GPUs. Okay. So next, this is an exploded view of the chassis. So you can see the chassis right here in the middle. And then on the left at the top, these are your 12 power supply units. And in the middle here, you've got your GPU sled and the front bezel. And then at the bottom, you've got your CPU sled. So all of these components slide into the front side of the chassis. And then on the right is the rear of the chassis. And there you will see these are some couplings that basically match up to the backside of the PSUs and offer you the ability to connect power cables. And then at the bottom here, this is a little fan sled for the 20 fans. Okay, and then this is another similar view. Okay, so again, you've got the chassis, you've got the power supply units, you've got the GPU sled, you've got the CPU sled, and you've got the front bezel. Okay, and then in the rear here is the here's the power supply coupling, so you can plug in your power cables, and then down here you've got your fan sled with your 20 fans. Okay, these are some of the primary components. So on the top, obviously, you see the empty chassis. Next to that, in orange, you see the GPU sled with the integrated CX8 NIC cards intended for your north and southbound. Let me make sure I'm saying that right. I think that's actually, yeah, your east-west, okay, Connect X6. So scratch what I was just saying. The GPU sled has the Connect X8, which is intended for GPU to GPU communications across different compute nodes in your GPU cluster, okay, across the backend network. Over here on the right, you've got the CPU sled, again in red, and that contains NICs for your north and southbound network connectivity, as well as your management and your local disk for storage. Here you see the front bezel. Here you see the GPU block. So this is basically what lives inside the GPU sled. And then here you see one of the fan modules. Okay, here's some of the additional components. So on the top, you can see one of the 12 power supply units that goes into the chassis. And then everything else in the red box are components that go now into the CPU sled. Okay, so on the top, you've got network connectivity options, including your Connect X7 or your B3220 or B3240 NIC cards. And then on the bottom, you've got an E1.S data drive. Okay, these are NVMe. I want to say the largest drives available right now are 15 terabits, or terabytes, but don't quote me on that. I would need to confirm that. The M.2 module, again, is protected by RAID 0 and contains boot drives for your operating system. And then the OCP module on the right is intended for out-of-band management. There's also a DC-SCM card that contains a 1 gig in-band management port and a 1 gig MLOM port. You're going to see both of those here in a minute. Okay, this is probably the most detailed and useful image. Turns out I was annotating this slide and then found out that the business unit provided an annotated slide, so you're going to see that a little bit later. But here you can clearly see that the power supply and GPU exhaust are marked as exiting the front side of the chassis. So again, remember which direction you're mounting the chassis in your rack based on your data center airflow requirements. In the orange rectangle, you've got the GPU sled that's consistent with the other slides. And as I was just saying, it contains the B3220 or the CX8, the Connect X8 east-west NICs, which you can reference in orange on the right side of the slide. And then in the red rectangle, you've got the CPU slide, which contains the B3220 and B3240 north and southbound NICs, which you can reference in red on the right side of the slide. It contains the DC-SCM or management module shown in dark blue on the right side. It contains the OCP out-of-band management module shown in purple on the bottom. It contains the data drive shown in green on the bottom, and those are located just above the OCP module. And then it also contains the M.2 boot drives shown in light blue on the bottom. Okay, so hopefully visually that makes sense in terms of where all the different components are located once they're installed in the chassis. Okay, and then finally, this is the rear of the chassis, which is very simple. You can see the 12 power supply units, couplings to the outlets or plugs and cables, and then you've also got the 20 fans that we've mentioned a couple times already. Okay, so if we get into a detailed view of the chassis and its components, here you can see where the GPU tray is located, highlighted in blue, should be in orange, but I just didn't change this slide. And then on the upper right there, you can see the GPU block that sits within the GPU sled, okay, or tray. So within that GPU block, we support 8 NVIDIA B300 GPUs, and we support, we have integrated into that sled the 8 ConnectX NICs for east-west traffic. Okay, here you can see each of the 8 internal B300 GPUs and how they map one-to-one to the 8 ConnectX 8 Super NICs, right? And this is for that GPU to GPU communication between compute nodes. So it's important to note what's in orange on the right. This is 2 by 400 gig connectivity to Ethernet. So one port will provide the north-south connectivity to the front-end network, and one port will provide the east-west connectivity to the back-end network. Again, intended for GPU to GPU communications within a cluster of servers. And actually, now that I'm thinking about my notes, I don't think that's correct. I think that both ports are going to go to your back-end network because this is for your east-west traffic. And the question is whether you want to break that out into 2 by 400 gig connectivity to Ethernet, or you want 1 by 800 gig connectivity to InfiniBand, which is supported. So yeah, I want to make that correction. I'm not sure what the reason is for the weird mapping order of GPUs to NICs, but I would just make a mental note of that and make sure you refer back to this slide as it makes sense to plan your network connectivity. Okay, this slide shows a more detailed view of the GPU to network to CPU connectivity in a semi-block diagram format. So following the bullet points on the right, you've got 8 B300 GPUs shown in blue, kind of near the bottom, just shy of the halfway mark in this slide. These all communicate internally within the chassis, southbound in the diagram through NVLink or NVSwitch, which is shown on the bottom of the diagram in green. And that's, each GPU has 18 connections. So you see 2 sets of 9 connections going to each GPU and redundant NV switches. Each one of those connections is 100 gigs, so 18 times 100 is 1.8 terabits per second, which is what I mentioned in terms of the performance we can offer. I mentioned this on the very first slide in the deck. So these also communicate internally within the chassis, which is shown northbound in the diagram through the CX8 Super NICs. Okay, all of this communication is using PCIe Gen 6. So in the lower right corner, I've highlighted the components that are supporting PCIe Gen 6. Okay, next we've got the CPU tray. So we've already kind of been through the details of what this looks like, but again, supports 2 Xeon CPUs. You've got a choice of CPU models there depending on your workload. I mentioned that you can support up to 32 128 gig DIMMs, which gives you up to, I think, 4 terabytes of RAM. And then you can see down on the bottom the couplings that allow the intra-chassis communication with other components via the chassis midplane. Now here's the BU annotated diagram that I mentioned. So the only things that I would really point out in this diagram are going to be items 4 and 5. So you've got the, I believe it's an Intel X710 OCP NIC that's intended for out-of-band host management. So you've got 2 ports for redundancy there. And then you've got the DC-SCM, which is your traditional management module. It's got, power buttons on it. It's got USB-C. It's got USB-A. On the left here, you've got a 1 gig port that's intended for management. And on the right, you've got another 1 gig port that is your MLOM. network connectivity port. You've got a display port, so you can hook up your KVM and basically manage the box from here. Okay, here's just a more detailed zoom in on that DC-SCM management module. Again, port 6 is the dedicated 1 gig management port. Port 3 is the 1 gig LAN port. And the rest of the ports are labeled here, and I'll just leave this here for your reference. Okay, now this slide shows all of the PCIe Gen 5 connectivity that's occurring within the box, including which CPUs the various components communicate through. And the bullets on the right side do a nice job of summarizing the connectivity that you see in the slide. Okay, so you see the 2 CPUs in orange down kind of near the bottom there. Each CPU connects to a dedicated Gen 5 PCIe switch. Each switch has connectivity to a pair of north-south NICs and 4 E1.S SSDs for a total of 8 in the chassis, and those go into the CPU sled. The X710 OCP NIC is connected through CPU 1. The M.2 boot RAID controller for your operating system is connected to CPU 2, and the DC-SCM features for management are also connected through CPU 1. Okay, so let's now get into just the high level networking, right? You guys have probably seen this slide. It's just been adapted for the C880, but we had similar slides for the C885 and the C845. So it just highlights the different types of networks and where those network connections happen in the chassis, right? So the first and most important network is the inter-GPU backend network, shown in dark blue, and those connect through the GPU sled on the ConnectX-8 east-west NICs. Okay, and then you've got your front-end network in this diagram that's shown in green. So this is how your clients would access applications running on the node. And so, the NICs that are shown here have 2 ports. And so one of those ports connects to the front-end network, and the other of those ports connects to external storage network in the event you need external storage because the internal storage is insufficient. And then the light blue shows connection to the OCP module for out-of-band management of the chassis connected to a management network. Okay, and then this slide just gives you the definition of each of those networks, and I'll just leave that here for your reference. There are additional slides that cover a dual plane design that allows for very scalable networking. So I didn't include them in this deck, but I'm going to point you at them should you need to reference them after this presentation. So there's a slide that details the ConnectX-8 NIC connectivity. There's another that details what connectivity would look like for a 256 GPU cluster. And there's another one that details what connectivity would look like for a 512 GPU cluster. So to see these, you want to search for the C880A TDM deck on SalesConnect.cisco.com. And that's where most of the slides in this deck are sourcing from. Okay, so from a storage perspective, right, we talked about the local boot drives, the 2 M.2 boot drives that you see in the lower left there in blue. That's for your operating system. It's protected by RAID 0. And then in the middle on the top in blue there, you see up to 8 E1.S NVMe SSE drives. Okay, this is a slide that talks a little bit about external storage and what that might look like. Obviously, this is all IP-based storage. And so, it just gives kind of a couple of examples here, and I'll leave this here for you to look through. Now, from a hardware and software configuration standpoint, we offered a slide just like this for the C885 and the C845. The very first row that you see there across the top refers to different PIDs or different SKUs. And if you then pick a SKU and look straight down that column, then you can see what the configuration options are within that particular SKU. So starting at the far left, the B301 includes obviously your 8 B300 SXM GPUs from NVIDIA, and that's true across all of the SKUs. We also support the 2 Intel Xeon 6th Gen CPUs. The 667 goes into most of the SKUs, but the 6767 shown over on the far right goes into the B308 SKU. Okay, so that's how you want to read this, and really the biggest differences here are obviously the amount of RAM depending on the SKUs that you pick, and the north-south NIC connectivity depending on the SKUs that you pick. So this is a great slide to reference when you're trying to put a quote together, depending on your memory and north-southbound NIC requirements, and also your CPU selection. Okay, everything else is pretty much uniform across all the SKUs. Now, in terms of the operating systems supported, we support VMware ESX9, we support Ubuntu 2404, we support Red Hat Enterprise Linux version 10, Red Hat CoreOS 4.18, and Rocky Linux 10.0. These are all going to be available as of first customer ship, and as I mentioned on the very first slide in this presentation, this was orderable in October of 2025, so last Q4 of last year. And then it's available for first customer ship in January. So we should be shipping out our first units literally as we speak. Okay, and then from a support and services perspective, you can see that we support success tracks for support. We've got 2 different levels. We've got enhanced, we've got signature, and you can see the details in terms of how those different levels of support break down, what support features they offer. So that's just something I'll leave here for your reference and that you might want to be familiar with. Okay, so key support services elements. Obviously, I just mentioned success tracks, enhanced, or signature tiers. Support is required when quoting out the chassis. You get a full suite of RMA options, and drive retention is available. Okay, so for more information, check out the link down at the bottom. All right, so what we did not cover, the slides that I kept out of this presentation, there is a very detailed C880A block diagram that I thought was just a little too busy, but it's available if you need it. All of the network connectivity options for the CX8 and the 256 or 512 GPU clusters, which I already mentioned. There's, I think, some additional slides on external storage. There's a couple of slides on power and cooling. Something to note there is that from a power perspective, when the chassis is at 100% load, that's going to pull 14.3 kilowatts of power, right, against your system. So you got to make sure that your power system is able to provide that. There's also some slides detailing out optics and cables. Those slides provide details on switch side and NIC side optics for both your front end and your back end networks, including patch cables, right? And there's single mode, there's multi-mode, there's copper breakout. So that's definitely going to be a series of slides that you're going to want to look at. And then finally, serviceability. So that includes, SKUs for ordering new or replacement parts. So again, definitely go to salesconnect.cisco.com and search for the C880A TDM deck in order to review those additional details. All right, I wanted to keep this video a reasonable length. I hope that provided you a good introduction to the C880A, and I appreciate you taking the time to watch. Thanks.